In stats today, we took the Z-curve and normal CDF a little further. We applied it to a real-world problem. But to start out, we practiced just with the calculator and normal CDF. So let's hold off on those two questions you see in the middle of the screen. Let's look at just the first one. I want to pull up normal CDF, and I want to get my lower to say negative infinity, and my upper to say 1.39, because I'm measuring to the left of 139. So on the calculator, I press Menu, Stats, Distributions, and I want normal CDF. Do not click PDF. I want normal CDF. And no, double check, because the calculator, those buttons jump around. You want CDF. So it defaults to negative infinity, so leave that alone. And let's type in, I forget what it was, 139. And we got our answer, 9177. Hopefully that one makes sense. This one, this word question here, is very backwards. And I used to teach this a completely different way. I used to make the students use table A, so that's why it's at this point in the lesson. And it's just backwards thinking. It's because they're asking what Z value represents an answer. It's like a Jeopardy question, I guess you could say, of 918. So we used to take table A and we'd skim all the proportions and look for 918, and we'd have our answer. But it's annoying because many times it's just not there. And you got to pick the number closest to the one you see, and it's annoying, it's not precise. But there's a super precise way. If you look right below normal CDF on the calculator, and you pick inverse normal. It's going to ask you for the area. I'll do it here in a second. And this, they want a percentile. Sometimes they're tricky, and they'll give you the top percent. So like on that second question right underneath it, they could have very well asked what Z-score represents the top 10%. We want the 90th percentile. All right? And then it lists mu and sigma. We'll talk about that later. Let's keep it 1 and 0 for now. So for this problem, we're going to type in 0.918 for the area, and it'll give us Z, just like that. It's just a backwards problem from what you're looking at, and I think you can see it is probably 1.39 if you look right above it, because 139 is in the 9177 percentile. So if I round to the, what is that, thousandths, it's about 139. But let's check on the calculator. So on the calculator, menu, stats, distributions, inverse normal. If you're holding an 84 calculator, you want to press second vars, and you see a screen just like this. And I think yours is abbreviated. It says like INV norm. Same idea though. Asks you the same questions. Area, 0.918, and leave mu and sigma alone. And we get Z, 139 or 139.17. Feel free to be more precise. You can write 17 if you want. Typically with z-scores, though, I stop at the hundredths place. So try out the second one, the 90th percentile. what z represents an area of 0.9. So inverse norm, area equals 0.9, leave mu alone, leave sigma alone, and we get 1.28. The remaining ones on this page, middle of your page of notes, are just practice, hopefully very, very easy. So maybe hit pause and try and get those. I bet you can get some of them without a calculator if you just cleverly look at them and see what they're asking for. I want to make sure I display the top right one, proportion of z's smaller than -5. So let's do that together. So this is the proportion of z's smaller than -5. Normal CDF. Smaller than -5, that means I have negative infinity and -5. And I get a really weird answer, I believe. Yep. 2.87 e to the -7. This says that proportion equals 0.1, 2, 3, 4, 5, 6, 2, 8, 7. If I have 4 zeros or more, let's just say 0. All right? You are A-okay to do that. The reason is because on the normal curve, -5 is way out here. And there is just microscopic amount of data. I can't even shade. I'll do a dot for my shading left of -5. There's just nothing out there. If I ask for greater than -5, isn't that pretty much asking for the entire z curve? That means it's approximately 1. So some of these you can do in your head. Greater than 2.12, hopefully you got 0.17. Less than -5, I would say approximately 0. Greater than -3.1, that's close to the whole curve. Less than 0, isn't that less than the mean? Shouldn't it be exactly 50%? I already said what this one is. Approximately the whole curve. Approximately half the curve. And if you don't believe me, type these in. You should get around those numbers. Greater than 5, approximately 0. And greater than or equal to 2.12 is the same exact answer as the first one. I think we have a couple more. Yep. These should be very easy on the calculator, and don't forget the or equals does not matter. So those should have the same answer. I would say it's insignificant whether we include 262 or not, because it's measuring all those microscopic numbers to the left of it. So we should get 85.99 for both answers. All right, let's take a look at a harder problem. All right, real life problem, because this is kind of meaningless, to be honest. We haven't really done much other than talk about this hypothetical bell curve that Gauss derived. But what if I know that a real life scenario follows the normal curve? Can't I find a value's z-score and then use all those theoretical proportions on the z-curve and apply them to this real-world problem? Supposedly, Tiger Woods, the balls that he drives are normally distributed with a mean of 304 and a standard deviation of 8. So one part of this question, you're required to say that this distribution is normal with a mean of 304 and a standard deviation of 8. So that's like, those are part of your points. You have to write that. This tells the reader that you're proving why you're allowed to use the normal CDF function or the z-score. If it's a free response problem, you must show your work, show your z-score. So we're going to go 297 minus the mean. And now we have things in terms of z. We know we have a z-score of negative 875. Now we're rephrasing the question. This question right here is asking how many x's are smaller, how many drives are smaller than 297. Well, I have no idea, because hypothetically, what percent of the time could he hit smaller than that? Well, if it follows the normal curve, now we know all we need to look up is the number of z's smaller than negative 875. So I showed my work. You can, at this point, just write your answer down. I'm going to pull up normal CDF on my calculator. You don't have to write this part. My lower is negative infinity. I'm out of room. My upper is negative 875. And my answer is 1908. Now, I don't just grade 1908. I need to see the question in proportion notation. I need to see the distribution. And I need to see work. So I need to see those 4 circled things. All right? If you want full points. If you just write 1908, there's a chance you will get 0 points on that problem. But once you define the distribution, you don't have to redefine it. So on part B, what percent of Tiger's drives travel at least 290? You can skip this first circle right here. And let's just write the question. At least 290. You still got to show your work. Let's do 290 minus 304 divided by 8. And we know that is negative 175. Now we know the question is asking z greater than negative 175. And when I look that up on normal CDF, I get 9599. All right. So let's do part C. Oh, by the way, I am grading the answer, your work, and the question. I need to see those 3 things. All right, moving on. Almost done. What percent of Tiger's drives travel between 305 and 325? Write it in a form of a question. Actually, I'm going to scroll down a little bit. Like in proportion notation. 305 to 325. Then I need to see two z-scores. And I get 0.125 and another z-score. And I get 2.625. Now I'm looking up this with normal CDF. And you should get, for a final answer, 4459. I am looking for this, and this. So if you want full points, you got to show me all four of those things. All right? All right, almost done. Proportion of exactly 290? Oh, that one is so nice. It's just 0. Done. It's got to be an interval. One value has no width, one value has no area, so it's just 0. And then lastly, top 10%. What marker represents the top 10%? This is referring to a 90th percentile, right? Or an area of 90. So I need to use inverse norm and type in an area of 0.9. Leave mu and sigma alone. I realize it's tempting to change those, but leave them alone. And that's going to give us a z-value. And I believe we already actually found that z-value just at the very beginning of the video. You get 1.28. And now you got to do some algebra and figure out what drive length represents a z-score of 128. So if this is my z-score, I need to solve for x. So I multiply both sides by 8. Then let's add 304. And we end up with 314.24. All right, this one, I need to see, for work, I need to see this step right here and the answer. And there's a few ways to write the question. I mean, if you wrote every bit that you see on the screen right now, you would get full credit. I like to rephrase this thing and write it like this. Because that's the question right there. So that's one way to get it. But me writing 90th percentile and all of that, you also account for that same question. So there's a few different ways to get full credit on this, but I do need to see the algebra over there on the right. All right, y'all have a great day. Bye.